Yes. All right. So, overall, how did you feel about this? You totally clueless and it went terrible, or you don't know yet? Marginally terrible. Okay. So we're going to go over this hard, so it should really be perfect. You should all be getting 10s on this, and you should be making corrections. I want you to do this in red so you can, I'm going to go over the correct solution, so that should be off to the side. But then I also want you to be able to get a feel for what the grading rubric looks like, which I'll put up in a minute, and see where you would have scored, and so on. Okay? So, here we go. So the first part is, remember this is based on a derivative of some equation you don't even know. It's a differential equation because the derivative is in Leibniz notation. And let's start with the first question. To do a tangent line, it feels like to do a tangent line, you would need to actually have the real original equation. And so you need to integrate first. And students feel like often they have to integrate first. But do you need the equation to find a tangent line? No. What do you need for a tangent line? A point and a slope. Both of those can be done without the original equation. The original equation is 1, 0, and the slope is the derivative at 1, 0. So what'd you get for a slope based on that derivative rule at 1, 0? -3. Do we all agree? Okay. A tangent line that is y equals -3 times the quantity x minus 1. And that's about good. Now, second question is use the tangent line to approximate f at 1.2. Approximate is a key word. So if you say f at 1.2 equals, you're going to be sorry. You mean approximately equal to. And the idea is that because x of 1.2 is so close to x of 1, that the tangent line value and the curve value, y values, are pretty close to the same, right? So we're using the tangent line to estimate. If I were to put in 1.2 into my tangent line, I get -0.6. Do you agree? Okay, cool. Let's grade that part where we're at so far. Okay. In terms of grading, did you plug 1, 0 into the slope, into the equation to get -3 for the derivative value? Okay, cool. Did you write a complete equation, y equals -3 times the quantity x minus 1? And then last but not least, the approximation point. Did you say that f of 1.2 is approximately equal to -0.6? Based on those three components, give yourself 0, 1, 2, or 3 out of 3. Did you find the slope correctly? Did you write a tangent line correctly? Now that tangent line question would actually be based on your slope. So if you're some total knucklehead that got the slope wrong, like -5 or something, but you put that -5 correctly into the tangent line equation, then you would still be eligible for points 2 and 3. Pretty generous. You with me? Any questions on that? Okay, here we go. Part B then is where the meat of the work comes. If they want y equals f of x, then they don't want the derivative. So how do I undo the derivative? Integrate. Okay, we've got to integrate, but the first step is key. You've got to get the y's and dy's together. That's called separation of variables, and the x's and dx's together. Something like that. So far, so good? Okay. Now, the left side will cause a lot of errors. What's the antiderivative there? Feels like e to the y, it's just e to the y, yeah? Be careful, it's really e to the denominator thing is a thing. It matters that it's in the denominator. And so in order to slow myself down, I probably do this mentally, but in order to slow myself down and make myself be careful, I use it. U is -y, du is -dy. And so with substitution, it becomes more like e to the u times -du. And so that antiderivative is -e to the -y. Yes?
Could you match all the absolute values?
No. Good question. The only time that this is natural log is if this is a single function or single variable to the first. And so I feel, it's pretty common that we feel like anytime you have a denominator to the first, it's natural log, but in this case it's not. Yeah. So that'll affect everything, actually. So you probably will have a chance to pick up about 3 out of 5. Okay, so what about the left side? A little easier, something like x cubed minus 3x squared plus a c. Any questions so far? Okay. Now, what's the next thing we got to do? 2 things we really need to do. Use the initial condition, solve for y. Doesn't really matter which order you do them. I'm in the business of using the initial condition first. In terms of AP strategy, it's the easiest points, so you go there first. They're the ones you pick up easiest. If I put 1, 0 in, then I get negative e to the 0 equals 1 minus 3 plus c. And so that would imply that c is negative 1 plus 2 or 1. Do you agree? Talk to me, people. How are you doing over there? Jet, how's it going? Is it? Maybe I should go slower. Negative 1 equals negative 2 plus c. It feels like it should be positive, isn't it? Okay. Okay, now then, I can throw that back into my equation. Negative e to the negative y equals x cubed minus 3x squared plus 1. This is sometimes starting out a source of confusion. In the book problems, they don't say solve for y. This piece here in the Saxon book, they don't say that. This is pretty common to AP though. What's implied is that you should solve for y as a function of x, as a single function of x. So now this is where the hardest part to get that last point come, solving for y. The algebra is almost always the issue. The first negative is no big deal. I could divide out a negative, and that's fine. Then, to solve for y, what? What's the the inverse of exponential, Alex? Natural log. So negative y equals natural log of no absolute value. That's a different case. That's when you integrate where that absolute value pops up. So y is the negative natural log of negative x cubed plus 3x squared minus 1. You have 2 places, if you had time in the AP test, where you could check that things are going well. At the very least, you can check that this gives you the initial condition. Does this make the point 1, 0? Well, if I put in 1, I'd get natural log of 1 plus 3 minus, negative 1 plus 3 minus 1. That's natural log of 1. That is 0, so it feels like at least the initial condition is being made. Whether this actually yields that derivative, that would take a little more work to verify. Okay? Are you with me? That's my answer. Now let's talk scoring. This is where I want to impress upon you the importance of the very first step. Okay? That was a lot of work, and therefore it's a lot of points. 6 points. 1 point is for separating the variables. Did you put the e and the y terms together and the x terms together? If you did, give yourself 1. In this case, sometimes they give you 2 points for the antiderivative, sometimes 1. In this case, they're giving you 1 point for each side's antiderivatives. The left side was a little tenuous. A lot of people make mistakes on the left side, but golly, come on, can we all integrate that right side and get those points, right? 1 point for the constant of integration. If you're not sure and you're running out of time, just separate the variables, do some kind of fudgy integration, and put a plus c there. Because separation of variables and constants of integration, that takes maybe 10 seconds to do, and you can get 2 points just like that. Okay? Using the initial condition to find the c of 1, that's the 5th point, and then solves for y is the 6th point. The problem here is that if you made an error in the integration, the question is then for the reader, is their mistake going to make the problem easier or harder? If your mistake makes the problem easier, then you're going to be out on a lot of it, besides maybe the constant of integration and using the initial. But the solve for y point is probably gone because you're going to be solving totally different equations than the other person did. Yes?
So when we integrated, we use the absolute values.
If you put absolute value, when you integrated, you said e to the natural log of e to the y,
Yeah.
you'll probably in for the separation of variables, in for the right side derivative, and in for the constant of integration and using the initial. They would read for you all on that. The solving for y you're probably out on because your equation is so different. So you're probably, if you do everything well, then you probably could get a 4 out of 6. Okay? Yes?
What's the constitutive integration?
The C.
The C?
Yeah. Do you have a C, and did you find a C?
Where's the wrong C?
Based on your antiderivatives, or you had the right antiderivatives, you didn't get C of 1. Is that what you mean?
I don't know what I did wrong, but I did something wrong somewhere along the way.
Okay. You would probably, if you have a C, and based on what your antiderivative step was here, if you correctly put in the constant, or the initial condition, and found the C based on what you thought the antiderivatives were, then you would get both of those points. Your last question would probably be out because you're wise.
Just gonna leave it as is.
Okay. This is what I want you, please pay attention really carefully. It's a lot of work, okay? That first step is separating the variables. This is the note they get. You will get 0 out of 6, nothing, if you don't show the separation of variables. They will not read it. They won't. No matter how beautifully you did all this work, you get a 0. They won't even look at it. Yes?
Can we show the separation and the integration one step?
You can. You can show, if you are here, then that is showing separation of variables, and the integration doesn't negate that. That's a good question. Okay? So you definitely have to have one of those two steps. But if you are, this problem is pretty hairy, okay? But the danger of that first step is if the problem's really clean, if you have dy dx equals whatever y, actually even think about the danger of this maybe. And it would be super tempting to just say, okay, well there obviously y equals 1/2 x squared plus c. You just dropped a 0 in this problem because you didn't show separation of variables, okay, when it was really easy. So the danger on this 0 here isn't when the problem's ugly, because you're going to go slow and be careful. The danger is when the problem's easy. That's when you're going to be tempted to just cut corners. You've got to show that step as much as you might think it's tedious and unnecessary. Understood? Okay, here we go. So give yourself 0, 1, 2, 3, 4, 5, or 6 out of 6, and hopefully, more than anything, you learn from your mistakes, and the next one will go a little better. This is going to involve a slight idea, an idea that we haven't really hit yet. So write yourself some notes and learn, and we will go back to it a little later. This actually appears in our book in set 124 or something like that. So it involves some learning. The first part should be just like the previous part. Did your tangent line go well? Did you say something like, I have a 0.12? What is your tangent line? Can somebody give me your tangent line? Actually, give me your slope. What is your slope? 8. And therefore, you have y minus 2 equals 8 times x minus 1 for a tangent line. Okay, that should have been easy points. I'm thinking because this has more parts, I doubt they're going to give you 3 here. They might give you 2. Let's see. Yeah, it's, oh, I didn't even estimate yet, did I? Oh, no, I did. Okay, so 1 point for finding the slope is 8, and 1 point for writing the tangent line. You can see that they moved the 2 over. None of that is important. They don't care what form you write the tangent line is. Point slope, slope intercept. Slope intercept is obviously the way that we go because it's the easiest. It requires least work. And in a tangent line, you'll always have a point of slope. B is the harder part. This is the part that you might not be familiar with. Use the tangent line equation to approximate f at 1.1. That's not a big deal. F at 1.1, this is where I at least imagine the 2 going over there. if I put 1.1 into my tangent line, it would be 2 plus 8 times 1.1 minus x. I'm putting 1.1 into my tangent line, 4x. Yeah? That's something like 2.8. Do you agree? Okay. Now, a huge part of calculus is estimation, but a second after that is this estimation more or less than the true value? Consider these two pictures. If you did a tangent line, if you did a tangent line in a case like this, and a tangent line in a case like this, it's supposed to be tangent. Well, the tangent line, so just to remind you, they meet at the point you're given. So in this case, it would be x equal 1. And the point you're doing or trying to estimate is 1.1. In this case, would my tangent line overestimate or underestimate the true curve value? Overestimate. Okay, you can see that the tangent line is above the true curve value, right? In this case, will the tangent line overestimate or underestimate the true curve value? Under. So what's it all about then? Whether you, to know if it's an over or an underestimate, it's all about concavity. It's all about the concavity. If the curve is concave up, if the second derivative is negative, sorry, there's concave down is my first picture, and the curve is concave down, then the tangent line will overestimate. But if the curve is, if the derivative is positive, so the curve is concave up, then the tangent line will underestimate. It's pretty common if they ask you, is your estimate more or less than the true value? And to answer that question, you need to get into the second derivative. That's why they're giving you the second derivative. If you're wondering over the course of the problem, why did they even give me that? That's why. That's how you're going to tell if it's an over or underestimate. I had to read a little carefully in here. They say, given that f of x is greater than 0, I thought, what? Why? Okay, for x between 1 and 1.1, from where we're tangent to where we're estimating, is the approximate and greater or less? Well, if f is greater than 0, and x is greater than 0, can't you agree that in this region x is greater than 0, we're talking 1 to 1.1, then what about the second derivative? Well, everything's positive. It's got to be greater than 0. Now, this is where this is not justification for them. This is for my purposes. To me, that means the curve is concave up. And so I would conclude that my estimate by the tangent line is an underestimate. Okay. The estimate, something like, because the second derivative is positive, the estimate is less than the true value. Anything? Questions? You're all quiet group. I don't like that.
We were going to have a snow day today.
Yeah, those are pretty bad, but I don't know. Maybe if we're in Florida. All right, C. Are you ready for the meat of the problem? C, separating the variables and integrating. Are you ready? Do you want to see the rubric? One was for the approximation. That was the soft point. Did you get that that was approximately equal to 2.8? Okay, I don't know if you can tell, but that's a way the equal sign. And then one for the second derivative is positive. Therefore, the estimate is less. The tangent line is less than the true function. Okay? Okay, so the true f of 1.1 is probably greater than 2.8, whatever that might be. All right, let's go to the last part, integrating. Question? Yes, sir.
What's with
2. 1 for the slope, 1 for the line. Okay? Okay, here we go. Separation of variables. We're solving for y. dy dx is, I can't remember, was it xy cubed or something?
Yeah.
Xy cubed. Okay, what's the most important step? Separating variables. This can be really hard algebra sometimes. This one's definitely not. dy over y cubed equals x dx. I would, again, you have to know yourself. I make mistakes when it's written like this. I would take the time to write it y to the negative 3 dy, because then I won't screw up my power rule. Okay, remember that exponent's negative. So now if I integrate, what's the antiderivative of y to the negative 3? Be a power rule. Y to the negative 2 over negative 2, right? Power rule. Raise it by 1, divide by the new. The other side is easy, 1/2 x squared. And then don't forget your constant integration. It doesn't really matter which side you put it on, but I will always put it on the x side because you're going to solve for y anyway. Should be over there to start with. Now what? Here's the initial condition. What is the initial condition? What is the point? 1, 2? Okay, if I put 1, 2 in, then I get something like, no, I'll probably put it back in the number. 2 to the negative 2 over negative 2 equals 1/2 plus c. What a stinking mess. What does that equal to? 2 to the negative 2 over negative 2. Negative 1/8 minus 1/2 equals c. So c is something like negative 5/8. Do you agree? Okay. So plugging that back in, y to the negative 2 over negative 2 equals 1/2 x squared minus 5. Put in my own writing, that's an 8, I think. Okay, now the last part. What do I do now? Solve for what? Okay, there's an algebra common area in here. This is why I chose this example. The negative 2 is a non-issue. Let's dump that. Negative x squared minus or plus 5/4. Do you agree with negative 2 moving step? Okay. Y to the negative 2. This is 1 over y squared. So is this okay? Take the reciprocal, take the reciprocal, take the reciprocal. Yes or no? Is it okay or not? Okay. More important than yes, Mr. Rickman, or not, it's the ability to investigate your own question. What about this? Do you agree that this? Do you agree that this is true? This is my specialty. I doubt myself all the time. I say, well, I don't know. Can I do that? You've got to be able to answer your own question. Do you know that to be true? Yeah. Can I flip, and flip and maintain truth? That's a no. You cannot do that. So that obviously from here to here doesn't wash. I can't take the reciprocal, reciprocal, reciprocal and maintain truth. That's a no-no. What do I need to do? There's a couple things I can think of. One is if you choose to flip, it's just like squaring or square rooting. If you do that, you've got to do it to the whole side. So if you go y squared equals, it's got to be 1 over the whole side. It's reciprocal. Now maybe a better way to go to take the whole side, maybe it'd be better to get a common denominator first and then take the reciprocal of both sides. That's a little cleaner. So if you did that, say you had 1 over y squared equals negative 4x squared plus 5 over 4, then it goes really nice to take the reciprocal and the reciprocal. It's a lot nicer. I think. Okay. So I'm going to proceed from there. Square root. When you square root, it's plus or minus. Is that my answer? Why? It's not an answer. Why not? You're supposed to find y as a single function of x. When x is one thing, y is one thing, not two things. So we need to choose, and we choose based on the initial condition. Which one makes the point? I can't even remember the initial condition. Which one would make y positive 2 when x is positive 1? Obviously, it'd have to be the positive, right? So y equals positive 4 over 5 minus 4. If you luck into it, if you don't do the plus or minus, then choose the positive. Say you didn't even know plus or minus, you will not get that point. They don't give you points for luck. You have to be intentional. Okay? The point breakdown. 1 for the separation of variables. Given that you know how important that is, that should have been easy. One point this time for the antiderivatives. The antiderivatives are pretty straightforward. I had my answer as y to the negative 2 over negative 2. Obviously, that's the same. So 1 point for antiderivatives. 1 point for did you put a constant of integration down when you integrate? Okay, that should be a soft point. 1 point for did you use the initial condition correctly based on your antiderivatives? And then 1 point for basically is your answer correct, solving for y. You can see that they actually, they don't show the plus or minus, but I can tell you from past years they would count off if you didn't show plus or minus and then choose plus. The domain is not required. It's nice and it's good math, but they don't grade for that. All right, so give yourself 0, 1, 2, 3, or 5. If you didn't show separation of variables, give yourself a 0 and then give yourself a little hat, and don't ever do that again. How are you doing? I have no idea when we get out of here. We're doing fun. We have 20 minutes. Are you doing okay? Michaela, how you doing? Good? Having a good day? Good, good. Okay. So, let's start with, I don't have the rubric for this one. I couldn't remember what year I pulled this from, so this one will just show the correct map. These are pretty common, by the way. If you get good at these, you're looking at really giving yourself good points on the AP test because you're pretty likely to get one. They're probably 90% of the 95% of the time. I can only remember 1 year where you didn't have one. A, check. Did you locate the point? Did you find the slope? You need to say, this is important. You need to communicate to the person, hey, I'm finding this is not crucial. But you definitely need to show that you're using the derivative to find the slope. If you just mentally calculate the slope and it appears in your tangent line, that's no good. You have to communicate that I'm using the derivative to find the slope. And it's something like 2 over root 3. I'm starting to doubt myself at that point, but I mean, how hard is it? So I guess that it is. And so y minus root 3 equals 2 over root 3. X minus 1 is your tangent. I imagine it'd be 1 for the slope and 1 for the tangent line, and then maybe 1 for the estimate. They do ask you to use it to approximate f at 1.2. F at 1.2 would be approximately equal to, if I move this over and found what the y would be, it would be root 3 plus 2 root 3 times an x of 1.2 minus 1. Okay, I told you last week that they don't require you to solve algebraically or numerically. So if you left that there, full credit. You couldn't leave tangent of pi over 2 in there, but you do not have to simplify. I don't know, maybe 2 times whatever. I don't know. I didn't see it clean enough, so that's what I did. Oh, this is 1.3, wasn't it? Oh, I know I must have moved the wrong there. I just lost points. Okay, are we cool? Okay. Roger, how you doing, bud? Good. Particular solution. What do you have to do? Separate variables. What do you get when you separate? Yes, ma'am.
I did that entire part.
Yeah, because you figured you needed the equation to do the tangent. Yeah, that's pretty common.
So can I just
You do not have to. They will grade
draw
for
an
it.
arrow?
Yeah, that's fine. They will grade your part A, and it's pretty common. But remember, you don't need the equation to do the tangent. All right. But yes, you're fine. Y dy equals x plus 1 dx. What if you, or surely this would be you, but what if you had that? Sure. Second one? Well, you just lost a really stupid separation of variable points because you can't remember basic algebra 1. This has to be in parentheses. It's the whole quantity times dx. That's a foolish, foolish, foolish point to lose. Okay? These are not just calculus teachers. They also teach algebra. They expect good algebra. Anyway, if I integrate 1/2 y squared equals 1/2 x squared plus an x plus a c, do you agree with my antiderivatives? Those are pretty easy antiderivatives, I think. Using the initial condition 1 root 3, 1/2 times root 3 squared equals 1/2 plus 1 plus c. 3 halves equals 3 halves plus c, which implies c is 0. Let's get the c right. Cool. 1/2 y squared equals 1/2 x squared plus x. Let's start solving for y. I'll clear the half. Y squared is x squared plus 2x. I'll square root y is plus or minus x squared plus 2x. And based on the initial condition, if it's supposed to pass through one positive root 3, we will choose which branch, the positive or negative branch. The positive. So y is the positive square root. Square plus 2x. It's pretty easy to check the initial condition. It's actually pretty easy to check the derivative. For the sake of future learning, can I just throw something at you here real quick? This will make my job easier in about a week. If I take the derivative of this, dy dx is 1 over 2 root x squared plus 2x times the derivative of the inside 2x plus 2, right? Do you agree? Okay. Now, if I divide out of 2, that is x plus 1 over x squared plus 2x. It says the derivative is supposed to be x plus 1 over y. Did I do the derivative wrong, or am I good? You're good because this is equal to y. So we're good. Okay? That idea of sometimes the substitution of the original equation into the derivative happens. So we're good. That's the same. All right. Okay. What does this differential equation imply? What normal equation? Exponential growth. In this case, they're not using a for amount, they're using y, so I guess I'd say the exponential equation is something like that. You are not expected to separate the variables and show, no, you're expected to know the connection and start there. Then you would say population doubles every 15 years, maybe 2y initials equals 1y initial every 15 years. That then is 2 equals e to the 15k. K is the natural log of 2 over 15, which is answer B. Okay, did that one go okay? Okay. This is the key sentence. The weight is increasing at a rate proportional to its weight. dw dt is proportional to weight. That then implies that weight is initial weight growing at an exponential rate, which actually is not true. It would grow logistically. Yes?
Do we have to show that?
You do not. Just trying to get the reasons. But no, you don't. Okay. They tell you enough to get the K. Do you agree? 9 pounds 3 months later implies 9 equals 6 e to the
3K.
3k, which means k is natural log of 1.5 divided by 3. And then you can solve the question, the amount at time 6 months old, weight at 6 is 6 pounds e to the that k times 6. And I got 13.5 or so. You agree? Okay. And then I had a mistake in this one, I apologize. This one, 0, 2, that's below the axis right away, you should be getting red flags. You should say, uh-oh, watch out for negatives. If this is revolved around the y-axis, then it's best, because this is not a function of y, it's a function of x, I would use an x slice, and therefore you will get what? Disc, washer, or shell? Shell. Cylindrical shells, when they're unwrapped, are the circumference for the top edge or bottom edge, the height for that edge, and the thickness in this case is dx. The r, what's r here? X. Height, be careful. Negative, it's the opposite of f of x. If you give these are all negative y values everywhere here. If you use a negative height, you will get a negative volume, and that's bad. Okay, so you need to say something like, instead of x squared minus 2, I said 2x minus x squared. I negated f of x. It is not okay to set the thing up wrong and then just ignore the negative weight. That is not okay. You should set up a positive volume. And so that's what it should look like from 0 to 2 pi. The antiderivative of 2x squared, you get the idea. My answer is 8 pi over here. Okay. This I had a typo on. I'm an idiot. So if you skip this, it's okay. But in the interest of getting a practice for the test that's valuable, okay, it was supposed to be plus 9. So that the curve, the cosine curve, and a parabola met together on the right side. I think with my curve, it was on the left and the right side, which is a no-no. You don't, and it revolves into itself. That's bad. Okay. So, because this is my error, let's just talk about how you would approach this. So you got a picture, you got a calculator, you got a graph. What would you do next? Say again? Find the intersection points. Let's say I called this A, B, and C, D. Okay? It's revolved around the y-axis. So that would be something like, I'm just going to look at a slice here. If I revolve that around the y-axis, then I'm looking at using x only and a shell, 2 pi r and the height. The radius, what's the radius? X. How will you find the height of these? Look at all these red segments. Upper minus lower. Upper being f of x or g of x. What's on top, the cosine or the parabola? The cosine. How embarrassing. That's f of x minus g of x. On the AP test, they'll give you different function names. They won't use y. They'll use f and g. It's expected, and in terms of time saving, please use their names. Don't write their names out. It's a time waster. Just call them f and g if they've been named. Now, if they're named y, like maybe in a college class they might do that, then you really have to use their names. You cannot, unless you said something like, let f of x equal in your work, then that would probably flow, okay? The limits are from, what, A to C, D to B, what? A to C, because we are using the x values, right? Biggest mistake is, among people that know what they're doing, is to forget the 2 pi. That is the most common error of people that know what they're doing. Okay? So you get the volume there. And, I don't expect you to have the answer because I screwed up the equation, but if it's not positive, you did something wrong. Okay? That's that. Well then. Shoot, we went over the whole freaking thing. Should we just say, call it 10 for everybody?
Yeah.
Is there anybody who's so lazy that they didn't write that down? Okay, cool. 10 for everybody. Don't turn it in. I got enough to grade. Tonight's homework then is differential equations, but you should be striving for perfection now. Learning from what you did wrong. That way you can use tonight's that homework we just went over for tonight. I want 9s aplenty. Okay? That's it. Have a lovely day. Actually, don't go anywhere if you don't. If you have some Friday,
all these weird numbers. I don't get it.
We have one yeah, one of our main actors cut out. I try to very
Zero pages.
beforehand
Oh, no.
on soundboard.
What do you do?
Dude, I was thinking.
Modulate everything. Keep the volume up. It's not like
Yeah, I don't know. I was gonna get I can just. I got something that makes no sense. When every oh, yes, that's I just sit on your desk. I didn't do this. Really? No, still not. Really? That's when you see this from or I'm gonna do it at lunch. See, I don't know. Intro Bonnie 192. That's there's no conclusion. No, there's no conclusion.
So there's just one thing.
This is
Yes, thank you, sir. 20 minutes there, calculator, 15 years. Both calculators. Anybody else have some Friday? Okay, cool. I have those graded, but I'll hand them back tomorrow, okay? We just don't have time to go them well.
I was like, dude, you didn't open up your sign on the first day.
That we have the